What happens? I feel you there. I certainly, know what you're talking about. Okay, so practice quiz. Well, I think there's 15 questions.
Nice.
It's kind of a weird one because some of the questions take a little bit longer, some are very fast. So anyway, the first question is one that takes a little bit longer because there's basically maybe 4 steps to this. So it just says find the equation of a tangent line to some graph. So just looking at it, you might know right off the bat that there's only half the answers really are sensible. If I draw a little picture of that 16 over x squared, looks like this. At x equals 2, graphing it might also just remind you of the fact that like you got to find the y value on this or you're going to have a harder time. What is the y value for, by the way, for the millions of fans on Twitch, this is number 1. So on the practice quiz. So yeah, this is 4. So this is the point 2, 4. Do you guys see what I mean about only half the answers being sensible? Because all the ones that show a positive slope are clearly wrong. And also, I mean, here's the thing. I mean, now that you've seen the picture, only one of the answers really makes sense. Yeah, because the y-intercept is clearly bigger than 4, and it's obviously not negative, so it's got to be f. It's just got to be f. But I'll show you real quick how to calculate this in case you're like, well, say I want to do the whole thing algebraically. You just take the derivative. You'd say f prime is negative 32 over x cubed. So f prime at 2 would be negative 32 divided by 8, which is negative 4. Okay, there you kind of knew that from the answer choices. And then so using point slope form, you'd go y minus 4 equals negative 4 times x minus 2. And then if you just you rearrange that, you've got negative 4 times negative 2 is 8, and you add the 4 over. Cool beans there? So I can't, and I think on the quiz, I'm not sure if you'll be able to rule out 5 wrong answers based on the graph alone. I can't remember. Anyway, so it's good to know both approaches. You gonna make it, bud? Mm-hmm. Yeah. You find that each eyeball gets like a mind of its own the more tired you are. Mm-hmm. Each eye is just kind of, yeah. I can't even really do it, I don't think.
No.
You'll make it, Trent.
I will.
Talk some. Same kind of question, number 2. What's the equation of the line normal to this graph when x is 3? Let's do it algebraically first. As an afterthought, we'll look at maybe the graph alone could have gotten us the answer, but I don't know. What do you guys think? Chain rule or quotient rule? Take the derivative of that. Quotient. We'll do both. How about that? just to please the fans. Okay, so number 2, you've got y equals 5 over x plus 2. So let's review. We have 2 ways of taking the derivative of this. One of them is called the quotient rule. So quotient rule would go 0 times x plus 2 minus 1 times 5 all over x plus 2 quantity squared, which can then be simplified. This is just 0. So negative 5 over x plus 2 squared. If you had wanted to do the chain rule instead, you would have rewritten it as y equals 5 times x plus 2 to the negative 1, giving you a derivative of negative 5 times x plus 2 to the negative 2. Don't forget the u prime if there is one. We just need 1 in this case. And of course, that's the exact same thing. So however you decide to do it, your derivative is going to be the same thing, negative 5 over x plus 2 squared. So what happens if you plug in 3? What do we get? Well, you get negative 5 over 5 squared. So you actually get negative 1/5. So what's the normal line? Normal is positive 5. So your equation is y minus something equals positive 5 times x minus something. What's the x value? 3. And the y value is 1. Now, of course, if you rearrange that, you get 5x. Let's see, you get minus 15 plus 1, minus 13. And there it goes. Turns out it's choice C. So, which means that this one certainly would have been doable with just the graph, because here's negative 2. If you go over to 3, and you draw the normal line, you can see that it's got a positive slope, and it must be crossing the y-axis at some really big negative number. So, are there any questions on that one? Oakley dokley. Oakley dokley. We're so glum today. It's good. It's good. All right. Moving on. So number 3 says use a linear approximation of this function near to estimate the value of f of 1.98. So the more long-winded way to word this question is, what is the best linear approximation you can get of that? It has to be linear. So anyway, the process is pretty simple. You first need to, so you need a point and a slope. So we're going to do point slope form, right? What's our point going to be? So that's half of the point. So the point is 2 comma, plug 2 in there, you get 16 minus 12. I'm getting 5. We're okay with that? Which is a good sign, because look at all the answers. What are they all pretty close to? 5. Certainly check your answer there. This is high tech, cutting edge technology over here.
It's in decimals. I've been doing it in fractions. Lame. What? I like fractions, okay?
Jesse, please forgive me. I'm so sorry.
Right.
Okay. The derivative is 4x cubed minus 6x. So then you say, well, what actually is the slope? Because I have the point and I also need the slope. So we're almost there. The slope would be, let's see, plug 2 in here. You get 8 times 4, 32, minus 6 times 2. That's a pretty nice number, 20. Okay, so it turns out that my slope is 20. My point was 2,5. So my equation is y minus 20. No, it's not. Y minus 5. Sorry. Equals the slope x minus. Oh my goodness. Can't write. All right, now what number do we plug in where? Not gonna be 2, it's gonna be the number we're trying to approximate. So what we've shown is that our function is approximately the same as this line in the neighborhood of 2. So if I plug in 1.98 here, what I get is, so 20, here's where you get to take a little bit of 20 times, it's negative 2 pennies, and then add the 5 over. So if you have 20 pennies is 20 cents, so 22 pennies is 40 cents. Or you could write that as 2 over 100 if you prefer fractions. I'm not gonna, so just be aware on your quiz. I'm not gonna ask you to do like 0.0017 multiplied by 0.032. Like, I'm not gonna ask you that. Okay, it's gonna be extremely simple stuff like this. So if you find yourself doing some kind of crazy long multiplication, it's no calculator, like the AP test. The AP test would like basically, they're the same way. They're not gonna ask you to do they're not gonna ask you what's 1,937 times 0.0296, but they would ask you something like this. So anyway, so my answer is $5 minus 40 pennies is $4.60. 4.6. Are we all okay with that, guys?
Mm-hmm.
Okay. Number 4, use a linear approximation of this function near x equals 25 to estimate the value of root 24.3. Looking at your guys' tired faces, let me just tell you, that just is like my lifeblood. You know? Really? Just kidding. That's terrible. You okay, Kate?
You know what my lifeblood is, Kate?
What?
Math.
You know, a full night, well, okay, that's true. A full night of sleep where I don't have to get up for school.
Ah,
that's,
yes.
That's pretty nice.
That is easy. And you know what didn't happen today? That.
Okay.
Pain.
Same. So there you go. Take my tired face. Man.
I might have asked you guys this before, but have any of you guys ever given like a speech or something where you're kind of public speaking and the entire audience is just like,
That's speech and debate in a nutshell. Are
Is
you
it-
kidding me?
All the time.
Everybody's
I thought they
waking
were-
up at 4:30.
I thought they were pretty captivated.
Yeah, or when you're giving a presentation that you actually put a lot of time into and you're like, wow, this is an interesting topic, and you get there and you're giving this presentation and you're using hand gestures and everybody, like, you're very excited and everybody's just kind of like,
Paul, it's fun like the first, maybe the second time, but by the end of the season, when everyone has heard everyone else's
Every
speeches,
speech, everybody's like
everybody
falling
checks,
asleep.
Like weekend for the past 3 months.
I just put everyone on mute.
You put everyone on mute?
Yeah, now you can just mute everyone, so you don't have to listen. Like, I made TikToks when I wasn't speaking. Like, I made like 6 TikToks yesterday.
Oh, I didn't know you were in speech debate. What event are you
The
doing?
rest of worked well because you got first place.
This-
I thought you got first.
What event are you doing, Lillian?
What?
What event are you doing?
MPA. I got.
Well, that's an easy event to just kind of ignore. Been there, done that. But most of the MPAs are actually kind of interesting, so I like
So-
them.
can I say about the fact that you
Anyway.
didn't get out, you don't have to listen to anybody else's speeches other than your opponents.
Yeah. But I also think it's really stressful.
Oh my God, yes it is.
So, anyway, so this problem, guys, number
That's it.
4, everyone understands why your point is 25.5,
Yes.
and then your slope would be, you gotta plug 25 in here. So what's our slope gonna end up being? 1/10. And so, if you can do that in your head, move backwards 0.7 units at a slope of 1/10, great. If you can do that in your head, that's awesome. If not, it's totally fine. My equation is y minus 5 equals 1/10 times x minus 25. And so if I plug the value I care about, 24.3 in there. Now here's, again, it's not, it's kind of arithmetic, maybe you're rusty on it, but it's gonna be negative 0.7, but a tenth of that. So what's a tenth of 0.7? 0.07. So you're gonna have,
This is not gonna end well for me.
this is gonna end up being negative 0.07, and then add that 5 over. So take 7 pennies away from $5, and you've got, from $25. No, from 5, I'm sorry,
Can't see.
from $5, and you get $4.93. So 4.93, it turns out is the answer. How do we feel about that?
Oh, these decimals are gonna be the death of me.
Decimals. Decibels.
It wouldn't even matter if I converted the fractions.
Let's see
I
that.
still wouldn't do well.
You can do fractions. This would be 7 tenths.
Well, I know, but what I mean is like doing that to decimal math does not come easily to me, like at all. At all. Like you do that and I'm like, oh, that makes sense now, but
Oh, that makes sense now.
but
Am I gonna
come
have to do-
tomorrow.
Am I gonna have to do long division here to try and figure out what
No.
1940ths is?
Yes.
Okay,
goodness.
1940ths, is that point four?
Okay, let's just
Let's do number 5.
let's just do this.
So you got the function 1 over x, so y equals 1 over x.
Yes.
Your derivative is negative 1 over x squared. So let's get our point and our slope. Our point is when x is 2, y is 1/2. Fraction.
Boo.
And our slope,
Fine, I'll do this in decimals.
our slop, is negative 1/4. Yep. Cool beans?
Mm-hmm.
Okay. So what you have here is y minus 1/2 equals the slope times x minus 2. And then we're going to plug in, it says 2.1 is our x value that we care about. So you plug 2.1 in. Okay. So basically you're going to have, so a quarter of a tenth. Think about that. Well, it's negative a quarter. So a quarter of a tenth, or it's the same as a tenth of a quarter. So it's negative. Does that make sense? This would be 0.25, so it's gonna be 0.025.
Yes.
Aha, I figured it
And
out.
then add the 0.5 over,
It looks like an 8.
okay? Think of it in how many thousandths you have. I have 500 thousandths. And take away 25 thousandths. So what you have is 475 thousandths.
Mm-hmm.
You okay with that?
It's okay if I can. Yeah, just I got the 19.
You do it with fractions. So so you went you called this a tenth.
Times of.
So negative a 40th plus a half is 20 40ths.
Yeah.
So let's see, once you have 19
Well,
40ths.
what I just went back and I converted them all to decimals
Yeah.
because I realized that I don't know what 1940ths is.
I agree, that's a tough one. What I would do is I would think of this as a half
Yeah, it's a half.
minus a half of a 20th.
Yeah,
And so a 20th is 0.05, so.
yeah. But then you end up just going back to what you're
Yeah,
doing.
you just
So
go
might as well just start at the, because,
No winning.
yeah, there's no winning here. There's no winning.
And guys, if you get stuck on this if you're doing your quiz tomorrow and you're stuck on this last arithmetic, I'll give you a hint. I'll be nice. I really, you ought to, I mean, this is not trivially easy. This is something that's part of doing stuff. But the focus is on, do you understand this stuff? So anyway, yeah.
Oh wait, I have to explain.
So if you get stuck-
I got that stuff.
I'll give you a hint too. I mean, on the quiz, like usual, the questions are a little bit easier than on the practice quiz.
Really?
Yeah.
Same.
No way. Bruh.
Okay,
Well,
it's not that
conceptually
hard.
they're identical, but I mean, I usually try to make it so the calculations are a little bit simpler. on the
If you want to
quiz.
make it easier, just copy the same button from the practice quiz to the quiz.
Well, then I would
The
learn
same
anything.
I'll just have you just write a little paragraph about your feelies, it's an A plus.
Let's do that.
Oh, God.
In your opinion, what's the slope of this tangent line? 7? Well, it was -3/4, but close enough.
Yeah.
You felt that was true, so that's your opinion.
If you're
J-Lo,
one of your 20 mul, or
I
you're one
hope
of your
that this
15 mulligans.
explanation makes
on the quiz,
sense when I give you my extra credit, but if it doesn't,
You're doing good.
okay.
You're doing good.
It's like a breakfast ball in golf. You hit your first drive way into the water. You're like, breakfast ball.
Yeah.
You do that in your quiz. Every question's a breakfast ball. All right. Number 6 is going to be a bit easier. There's no function to take the derivative of. So for number 6, the calculus here, the idea is, can you look at that wording and turn it into this? I mean, this step is this is sort of an intermediate step that you might not need to write this out to understand it, but the point is 2/8, and the slop is 27. So your equation is y minus 8 equals 27 times x minus 2, and we are going to go ahead and plug in 2.1. This one's a bit easier, right? 1/10 of 27 is 2.7. Add the 8 over, you get 10.7. Okay? Cool beans? Cool beans. All right, and then 7's very similar. For number 7, you guys are probably okay with me going straight to the equation, right? It's y minus 15 equals -13 times x minus 4. I can certainly go back if there's questions, but so number 7, right? Because the point was 415, the slope was -13. Cool beans?
Mhm.
Okay, great. And we're going to plug in 4.1. You might have noticed a pattern on these. When the slope is negative, right, moving to the right of 4 in this case gets you a lower y value, that kind of thing. So 1/10 of -13 is -1.3, and we add the 15 over. So that's sort of the rise you got out of your little run of 0.1. A run of 0.1 gives you a rise of -1.3 because the slope is -13. The answer is 13.7.
What? Behind you.
Yes.
What is? Turn off the music.
Yeah. Sorry, I really could not hear you. I mean, it's good that I can't hear you because I'm trying to do this on my own and not listen to people. Because I want to make sure that I can do it. But I will turn it down a little bit. so-
Okay, number 8, very similar. It's going to be y minus 40. 40 is my y value. Equals, what's my slop? 23 times x minus 5. You guys all cool with that? Make sense?
Mhm.
What gets plugged in?
Wait.
4.8. Now a little bit, maybe a little bit more challenging, possibly.
Mhm.
If Trenton collapses from excitement, 'cause you guys know CPR, right? It's hard. I'm sorry, Trenton.
Somewhat.
My heart goes out to you. Okay, so 0.1, 1/10 of this is 2.3. So 2/10 would be 4.6, but it's negative because it's 4.8 minus 5 is -0.2, -4.6. So we're all cool with that, and then add the 40 over.
Mhm.
Okay, so what do you get? 35.4. Some Red Bull soda pops.
What did you just say?
I got
That's
some
it.
Red Bull soda pops if you want one.
Oh, I thought you said Red Bull.
Bread soda pops. Yeah, bread flavored soda. You like bread flavored soda?
The sad thing is that it's a thing.
Is it?
Yeah.
All right, number 9.
All right, never.
The rest of the questions are all about the mean value theorem. Okay? Just a theorem. Okay. It says, what's the x value where the instantaneous rate of change is equal to the average rate of change for this function? So the first thing you got to do on a question like this is say, does the mean value theorem apply? If it's some kind of discontinuous function or a pointy function or something like that, then you can just choose F.
For the rest of the things.
Oh, yes, every question, yeah. So, okay, your function is 2x cubed minus 5x, and your interval is 0 to 2. So let's get the average rate of change. Just rise over run. Plug 2 in, you get 2 times 8, 16. 16 minus 10 is 6. Remember, average rate of change is it's f of b minus f of a over b minus a, where this is your a and this is your b. Cool beans?
Yeah.
So plugging in 2 gets you 6. Plugging in 0 gets you 0. So that's easy. And then divided by 2 minus 0. So the average rate of change is 3. Okay. I certainly would advise taking your time on this calculation. Okay, because plugging in 2 is not super easy, right? It's not. The 6 was not like a really obvious number. Okay, so anyway, the question is, when will the instantaneous rate of change, aka the derivative, when will that thing be equal to 3? So the derivative of this would be 6x squared minus 5. And I'm asking, when's it equal to 3? So if you solve that, 8 divided by 6 is 4/3. Everyone's okay with that? And so the answer is, now of course, the negative answer is not in this interval, so just a positive answer. Question?
Square root of 4/3.
Cool beans?
Well, can you please quiz the whole of one answer?
Every question is an answer.
Just one answer.
Don't tell us.
Yeah, but don't tell us, like, or when it's gonna happen. Not triple.
What would be really funny is to make 2 quiz, or just make 3 versions. One where every answer is true, all true, false. One where every answer is true.
Oh.
One where every answer is false. And then one where it's just a mix. Because then I guarantee you 30 minutes or even 10 minutes of the quiz, someone's going to be like, what's going on? Like every question is true. And then the person who had them all false is going to be like, oh my God, what is that?
That would be so cruel.
They'll kill them out.
I might have to give up my oath of nonviolence and punishment.
That would be awful.
That
So-
would be the end, I think. I'd be like, nope, we're done.
Gone.
Boom.
Well, you guys have heard of the famous quiz where it says, you say, read all the instructions.
And
The front of the
then
quiz.
it says is write your name. Or
Yeah,
something.
and it's a bunch of really hard questions or even weird stuff like, oh,
Miss
get up on your
Burgess
desk.
did that to us once.
Yeah.
It was like, okay, like read the instructions, and the instructions were, don't do any of these problems and write a smiley face on the bottom. And I really almost did all of it. So
Yeah.
it's good that I reread the instructions.
Okay, so this question, visually it's just on a square root curve, there's the average rate of change between 1 and 15 and 16, sorry. Okay, there's this average rate of change. The question is, at what point along the curve is the slope equal to the average rate of change? So same procedure. Calculate the average rate of change. So you plug in 16, you get 4. Plug in 1, you get 1. And divide it by the run. So 3/15 is 1/5. That's a nice number. So our answer would be, well, set the derivative equal to this. So the derivative of this function is 1 over 2 root x. When does that equal 1/5? A little bit of pretty simple algebra here. You rearrange, you get 5/2 equals root x. Square both sides. People often get to this step and they square root both sides. Then you'll have the square root of the square root of x. You square both sides. 25 quarters is the answer. Cool beans? Okay. 11. Given this function, let's see if someone will make my day here. Maybe. Behold. Not yet. The answer? Well, who? So I have a simple question for you. 2 words. Who dis? Mr. Humpty Dumpty. Wow, Mr. Humpty Dumpty. He's an even function, right? Mr. Humpty Dumpty. I guess what's not obvious is, I mean, do we know for sure that it's not pointy up there? That's a difficult question, but between -1 and 1, that's symmetrical. So what's the average rate of change? 0. We can calculate it too. There's nothing wrong with. So I'm just trying to show you that you can answer this question without doing any actual calculation. The answer is E. But let's say that didn't occur to you, it's fine. Plug in 1, you get 1/2. Plug in -1, you get 1/2. So the average rate of change is 0. If you take the derivative, it's 0 minus 2x times 1 over x squared plus 1 squared. And then you ask the question, well, what value of x would make this whole thing equal to 0? Well, 0. You can also see, hopefully, that this proves that the derivative exists everywhere because this derivative function has no discontinuities. Yeah?
Mhm.
Yeah. All right. Here's your moment, Hannah. F. Press F to pay respects. Okay? Yes. Yes. The mean value theorem does not apply to this function. This is question 12 for the billions of fans at home. Number 12 is discontinuous at 2. So the mean value theorem does not apply. This one, I believe, even if you do the calculation, well, if you graph that, in case you're wondering, you're like, well, I know it's not guaranteed to exist, but could it exist? It looks like this. So the average rate of change between 1 and 5 is a positive number, but all those slops are negative. So not only is your value not guaranteed to exist, your value does not exist at all. So last couple of questions are just conceptual questions, then we're done. Yay. Yay. Yay.
Noise of the hour.
Okay, so 13. Maybe I'll just point this over here for the last couple. Okay. Wow, this is good cinematography. Hopefully, if anyone's watching this, have the quiz pulled up. You can see the question. 13. For which of these functions would the mean value theorem apply between 1 and 5? The interval 1 to 5. So basically, fancy worded question of which of these functions have no pointies, no asymptotes, no discontinuities whatsoever between 1 and 5? Huh?
Over the triple?
Over that specific interval, exactly. Because they all have discontinuities. Or no, they all have some non-differentiable point. Number 1 is Mr. Pointy Birdie. He pointy at 3. Yeah, so number 1 is pointy at 3, right? If you're pointy at 3, then that's a non-differentiable spot between 1 and 5. Mean value theorem doesn't apply. Remember, you got to be continuous and differentiable over the whole interval. Okay, you got to be connected, no gaps, no jumps, and you also have to have no pointies. So number 1, by having a pointy at 3, you guys don't remember Mr. Birdie, right? Please don't break my heart. Mr. Birdie.
Mr. Birdie.
He's Mr. Birdie shifted over 3 units. This guy shifted over 3 units. This guy is a little bit weirder, but this guy's only discontinuity is where? -3. So this guy's okay. Between 1 and 5, he's differentiable and continuous. So the only problem with number 3 would be if you had -3 in your interval, then that's not going to work. Okay. Number 14. So the answer to that was 3 only. 3 only. Okay. So 14 and 15. Just got to read them really carefully. Consider a function f which is continuous from 2 to 7, but is non-differentiable at 4. Okay, so that kind of narrows it down. What is happening at 4 for this function?
Pointy.
He's pointy. So does the mean value theorem apply to this function? No, not between 2 and 7. So now the answer choices are just basically asking you, do you understand what the mean value theorem says? So since the mean value theorem doesn't apply, by the way, the average rate of change would be 15 divided by 5, or 3. That's where this 3 is coming from. True or false? There must be a value between 2 and 7 where the derivative is 3. No, because the mean value theorem doesn't apply. There could be such a value, but it's not guaranteed. There cannot be such a value, or none of those statements are true.
There could be.
There could be. So the answer is B. So I'll give you 2 examples. So here's one. So if you have a pointee, so here's 2, here's 7. So say your function goes, what's that noise?
Oh.
Okay, so your function did this, and there's a pointee at somewhere between 2 and 7, then in this case, there is no spot on the graph where the derivative is equal to this average rate of change, but you could certainly have a function that does like this, and then yeah, there's on this one, there's actually 2 spots where the derivative is equal to the average rate of change. So does that make sense? Maybe I'm probably belaboring the point here, but so it would be very, very, very difficult to guarantee that there was no possible value where the derivative wasn't 3. So I guess maybe if you somehow guaranteed that the slope was negative. Last question is, they're telling us that the function is differentiable between 3 and 7, so the answer is going to be there must be such a value. That's all. Those 2 questions should hopefully be slam dunks because I believe when the quiz are worded almost the exact same way. All right. Submit. Did we get them all? Let's see. We did, guys. Wow. Wow, the excitement in here is palpable.
Whoop, whoop.